Hi, I'm Ali Sayed, Master of Science in Mechanical Engineering. Now I'm going to give a brief description about Design for Six Sigma, which is DFSS. This is one of the methodology what we use in the industries to find the quality of the product in the market. Well, to start with, we'll see why we need the quality procedures, why we need the quality approaches in the industry. Once the product has been designed and it's packed and everything is then launched in the market, and after a while of 3 months or 6 months or of a year, we'll get the feedback from the customers. Like we'll get the defects what we had in the component. So, for example, that thing is actually counted as 200 defects per parts per million or 600 parts per million. That is a quantitative actually what we get for the product. So the whole methodology of the quality methods what we use over here is to reduce the number, to reduce the defects as early as possible, to reduce the problems what we have in the early stage of the product. So in the market, in the industry, we have many methods which we actually use, like Six Sigma, DFSS, like the methodologies is DMA-IC and DMA-DB methods and DFSS. Why is that all the industries are very much concentrated in using DFSS process at the moment? The reason is because the Six Sigma, the standard method what they use for the Six Sigma is DMA-IC. This has been like started by an employee in the Motorola, but this has been widely used in all the industries even at the moment. But why the DFSS has come into consideration? Because you can achieve the quality of the product or a component, but there is a limitation for the design of the component, because this process comes into consideration of once you finalize the design and once it goes into the usage, you will put the Six Sigma into consideration for the service, or you put into the Six Sigma into the consideration for the manufacturing processes or the application of the product. So you can increase the quality in the service or you can increase the quality in the component, but there is a limitation for the design. You cannot change the design of the component, because in the concept generation we go with finalize with the design, we go, and then at the end once the product is ready, we apply the Six Sigma procedure. So that is when like DMA-IC methodology is used. That is used when everything is confirmed actually. So already using the processes which are already used in the market, which are already used by the industry on the product, only then the Six Sigma comes into the consideration. Whereas DFSS, which is designed for Six Sigma, can be used at all the phases of the product development cycles. So even from the voice of the customers, like finding the problems or finding the necessities of the customers with respect to the product, even from that point to the launch of the product, we can use this DFSS methodology. This DFSS methodology is commonly known as DMA-DB, which is define, measure, analyze, design and verify. Here which has other name, which is known as IDOV, which is nothing but identify, design, optimize and validate. Here I am going to give the whole brief description using the methodology IDOV. Well, DFSS methodology, as I explained, is identify. In the identify section, we just find out what is the problems the customers is having for the redesign of the component, or what is the application for the customers for the new design of the component, and then we list out by using the ranking by the priority of the problems or the applications. And then in the design, we generate the concept, we design the component, and we do the testing of the load or the stress analysis or anything, and then we do the control plans in that. Whereas in the optimize, we test the product in the dynamic conditions, and we see if there is anything we can change in the design, if there is anything we can change in the statistical behavior of the component or anything. And in the validate, we do the testing, like we validate the component within its limits, or we validate the components within its conditions, and then we launch the product. We'll see the brief description about this over here in the DFSS curriculum. Before that, I want to explain on what basis this whole process of the quality method has been put on. Here is a standard chart diagram what we use for the process capability, which is nothing but finding out its tolerances, its quality limits, like which is -3 sigma, and this is 3 sigma. This -3 sigma is nothing but the lower tolerance, and this is the higher tolerance, upper limit and the lower limit. And then you calculate the CP, which is a process capability for the dimension of that component, which is nothing but upper limit minus lower limit by the standard deviation of the whole tolerances of the component. By using that value of the CP, you will define what is the upper limit range and the lower limit range of the component, and then you go ahead with the Six Sigma concept. It means like once you get the upper limit and lower limit, in this range, the component will be robust, the component will be reliable, the component will not fail, the component will fulfill the whole process or the condition what the system requires where that component is used. So that is the whole process which we can understand using this. So what I am going to explain over here, quality, whether it with respect to your manufacturing or whether with respect to your dimension or with respect to your static tolerance or anything, everything is based on this concept of this process capability graph. Now let's go with the DFSS curriculum. Well, this is actually a standard chart what actually industry used to find out the curriculum topics or the tools or the methods what industry used for their product. So firstly, as I explained earlier, that I am going with IDOB methodology. So first is I, which is identify. Here I will explain with respect to all the phases the product will go in the product development cycle. So first one is identify the customer requirements. For the new product design, we need to know where that component is used. We need to know what is the applications of that component. For the redesign of the component, we need to know what is the problems the customer is facing because the component has went to the stage where it has to be redesigned. So we need to do through thorough research. The tools what we use for this is like listening to the customers, doing the market research, finding out the surveys with the industries and the customers who use that component, and finding the problems or finding the applications of it. And then what you have to do is you have to list it out with respect to the prioritize, like what is the most prioritized way, like ranking of the problems or ranking of the applications in the industry or the usage of the component, and then that will give a brief idea to on which of the parts of the component we need to concentrate. Like for example, for any component, like for example, if you just take a normal pen. For example, if you take a pen, the main component, the main function of the pen is to write on the paper. Whereas if you just check with what actually it does with respect to the lateral thinking, you can write with it, you can play with it, you can hit with it, you can do anything. But what is the most prioritized thing over here? It is just to write. So it goes according to the prioritize of this. So we have different methods in the industry to prioritize the problems and the applications, which can also be done by using the QFD, which is nothing but quality function deployment. So this is a whole actually chart which will give the ranking of the problems and the applications for the customer requirements. So this is the first phase of the product development cycle, where you will find out, you will generate the information about the product with respect to the customers. And then the second phase, what we are going to explain in the design part, is conceptual design and the preliminary design. Here, once we got the information what the customer requires, we generate the concept. We generate how this product actually should look like. We generate a process, how actually this product should work. So this everything has been generated in this section, where we'll clarify and explore the applications and the problems, and then we generate the ideas internally, like how the product should be, like where exactly it has to be fixed into the system or the other product. Like every component is linked with some other component in all the machinery. So while designing that or while generating the concept for that, we need to have the idea of all the components which are getting surrounded with that. So we need to have the ideas, we need to generate the ideas externally and internally. Externally is like if there is already a component in the market by competitors or anything where that is used in any other applications, we need to get the ideas like how it will affect there externally and internally, which is the process of the machinery. So generating ideas and then creating the design concepts. So even for the creating of design concept, there are few methods, there are few tools and tables where where that will help you to finalize the design, finalize the concept design. Even for all the product design engineers, when they sit and want to design something, they will get 3 to 4 ideas, 3 to 4 types of designs, like 3 to 4 different designs for a component. So what is method they use? What is the process they use for designing, for finalizing the final design? Even for that, we have the methods like quality, function, deployment, and the trees. These are the methods which actually they use to finalize the design. So similarly, we need to evaluate the design. If that will be capable enough to be fulfill its requirement in the machinery, will that stand within its limits, of the component. So that is what we need to do with the evaluation of the design. And also we do the load testing or stress analysis, structural analysis, all the testings which we have in the latest softwares at the moment, like ANSYS, NASA, Pattern, anything. So we use all the things to do all the testing, and then we'll evaluate the design. If there is any weak links in the component which are getting failed, then we redesign, we go back again we generate the concept, again we use the design. So that is the evaluate of the design, and then you predict the design capability, which is nothing but defining the capability of the product, if that can be used, where exactly it has to be within its limits without the failure. So these are actually the topics which we cover in this design part. And what are the tools we are using over here? QFD, quality functional deployment, and the tricks, which is nothing but a theory of the innovative principles actually, which has already been defined to find out the problems which it can face, so that we can solve it before it is released in the market. So it's nothing but finding out, assuming or expecting the problem or where this product can fail. What are the weak links we have in the product? So just thinking about it, and then we try to solve it before releasing it to the market. And the robust design, which can be found out by using a graph between the load margin and the safety margin, and FMEA, which is nothing but failure mode and effect analysis. This is also an analysis where you will list out all the functions in the product, and then you will list out what are the possible failures in that function, and then what are the things which are causing that failure in that function, and then you list out its occurrence, severity, or detectability, and then you will find the risk priority number for each and every cause in the failure. So this will help to find out which is the most common failure in that product. So from that thing you will start solving the problems actually, and then you will make your product robust and you will make your product reliable. So this is a very commonly used method in the industry as well. And the process mapping is also used for this is one of the methods which we use for selecting the manufacturing process. Like if there is any product, if you got class between 2 and 3 processes in the manufacturing, either that can be a injection molding or sand casting, or else you can go with the turning or boring, then there is a method, industrial method, which is nothing but finding the manufacturing risk quality. So manufacturing process risk. So once you got that, it will be easy for you to decide which manufacturing process will have the less risk. So which can be found out by using the process maps, where you will also finalize the surface finish of the component. So that is the process mapping. So this is the second stage of the part where you will go for the concept design and the preliminary design. So once that is done, we go for the second one, the third one, which is optimize. Here you will finalize the design, and then you will verify the product and the processes which the component is going through, and then you will launch it. So first we'll go with the final design. In this part we will test the component in the dynamic conditions. We'll define the transfer function where this component can be used. What will be the effect of this component in the dynamic conditions of the machinery? So we find all the transfer functions, and then we optimize the design and the value. Optimizing is nothing but it's a final check, it's a final test of the component to see if there is anything you can change in the design, if there is anything which you can do in the change of the design of the component by keeping it within the limits. So, and then you will develop the control plans, and then you conduct test for function. So test is nothing but like for making a prototype and then testing to its extreme conditions, which is like halt and hazard, the most testing facilities which we have in the market at the moment. And then you verify the process, and then you implement and design. These are the actual topics which we'll cover in this optimize. The tools what we use over here is trace, control plans, prototype, and the piloting, which is nothing but which I already explained about testing the product to its extreme conditions, and the pre-launch and the launch. Well, actually the pre-launch and the launch what we have over here is actually launched for the actual application what the product is made for. And then so that is the final design, product and process verification at the launch. And the last one what we got over here is validate, is nothing but a post-launch. It's a measurement and process controls and the leverage at the other applications. Why does a post-launch comes into the consideration is because once you get a requirement from the customer to design or manufacture a product, you will do that, and later on you will come to know that product can be used in some other applications. So what you do is you post-launch it with the exposure of the other applications where you can use that component. So that is a post-launch. So this is the this is the brief and the short like DFSS curriculum tools and methods table where we have where we are seeing that how DFSS can be used at every single stage of the product development cycle from the voice of the customers to the till the launch of the whole process of the product. So this is the DFSS. So how will it differ with the Six Sigma, which I already explained? I just want to repeat at the end is because like Six Sigma is a very good process, but the point is like it will get constrained with the design limits. Whereas in DFSS, as we are using it at the concept generation and the concept finalizing the design, we use DFSS to select the design which will give the more quality, which will be more, which will lead to the less defects parts per million. So as we are using DFSS in the concept generation of the design, there is no limitation for the design. Whereas in Six Sigma we cannot use that is the reason we are having limitations in the design. So that is the reason why most of the companies will go for DFSS. If the design complication is not an important thing, then all the companies will go for Six Sigma. Now at the end we'll see what is the impacts of DFSS actually. So first thing is this shorter development cycle. As we already know this process of development cycle, and we have the quality methods to decide which one is the most reliable and the robust one. So it will be easy for us. So the development cycles will get shorter. And the reduction in the design process, as we already have the manufacturing processes to decide which is the most reliable one. And the reduced early life cycle, as at every single stage of the product development cycle, as we are checking the quality, there will be very less failures in the early stages of the component. And the increased initial customer satisfaction. As lesser failures, the higher will be the satisfaction of the customers, and the greater efficiency in the design resource and the easier integration of the design groups. So this is the brief about the DFSS. This is the very commonly this is very commonly used now in the in companies where the component and the design of the product is very complex. So I hope this has given a brief idea about the DFSS for you. Thank you.